All right. So what we did last time is we went through the arithmetic of the equation, which is how to interpret the equation in terms of moles, in terms of mass, and in terms of mole of volume. In other words, we interpret means how to read a chemical equation using one of these type of measurements, whether you're talking about the mass or the volume or the number of moles. And as you already recall from chapter 10, that we're talking about convergence between the count, volume, and mass. So what we will do today is apply all what we learn on chemical reactions. So we will be doing chemical calculation, actual chemical calculations. Starting with the question and picture for today. And I already shared this with you before, but which is if you are working for a manufacturer and you would like to know how much starting material you need to have in order to get a desired product, then in that case, indeed, you need a chemical equation for sure. And based on the balanced chemical equation of the reaction, you can determine how much reactants you need in order to get certain product. Anyway, let's see our objectives for today, which is explain how more ratios are extracted or derived from a chemical, or used in a chemical calculations. Also, this one I already talked to you about, which is if you have a chemical equation and a relationship, mole relationship between the reactants and the products, of course you can derive convergent factors between the reactants and the product. In other words, if we have, let's say, A moles of X plus B moles of Y producing C moles of W. Now, A and B and C are the coefficient in a chemical reaction, in a balanced chemical reaction. So if you were given the number of moles of X, let's say we have X small moles of X, or let's put it another simple, let's say, for example, if we have 10 moles of X, then how many moles of W we're going to produce. Based on that, you can, in order to do that, you can derive what we call a convergent factor from the equation, and that is the relationship between X and W is basically we have W OW moles divided by, or CW moles divided by A moles or X moles. And the same thing, the relationship between Y and W and between Y and X and so on. Then we're going to explain to you in the second objective how to, the general procedure for doing the stoichiometric analysis. Writing or deriving a Moore ratio. First of all, what is the meaning of a Moore ratio? A Moore ratio is basically a convergent factor that you can derive from the coefficient of a balanced chemical equation that is interpreted in terms of moles. What does that exactly means? It means that we can use these convergent factors in order to perform a chemical calculations where we can use these convergent factors to go from the reactants or the moles of the reactants to the moles of the product and backward if needed. Here's an example that we talked about last time, which is the chemical equation used to make ammonia. And that is by reacting 1 mole of nitrogen plus 3 moles of hydrogen to produce 2 moles of ammonia. This is the way we interpret an equation. This is the way we read an equation, which is, again, that is 1 mole of nitrogen reacted with 3 moles of hydrogen to produce 2 moles of ammonia. And this is based on a balanced chemical equation. Have you noticed? It is balanced chemical equation. From this equation, you can derive 3 convergent factors, and that is just a mole ratio between the reactants themselves and between the reactants and the products. For example, if you look at the first one here, that is the mole ratio between nitrogen and hydrogen. They are 1 to 3. So if we have 1 mole of, for each, that's the meaning of it. For each 1 mole of nitrogen, you need 3 moles of hydrogen to react with it. And the same thing over here between ammonia and nitrogen, that for each 1 mole of nitrogen, you will produce 2 moles of ammonia. And in this conversion factor over here, for each 3 moles of hydrogen, you will produce 2 moles of ammonia. All these 3 conversion factors were derived from the mole ratios, which is 1 to 3 to 2, as per the balanced chemical equation. This is very important, that you make sure that your chemical equation is balanced before you start deriving any convergent factors. One of the mistakes that people make is in a typical question in a homework or an exam or a quiz, where they don't first check if the equation is balanced or not. Okay, so here's the way we do that. If we have an equation which is basically we have X moles is converted into how many moles of W. So if we have a reaction which is in this case a reaction that is G is going to W, that's just a chemical reaction, and we have A moles of G and B moles of W. So in that case, the number of moles of W produced from X moles of G is by deriving the conversion factor, which is B moles of W divided by A moles of G, and that is derived from this equation. So this is your conversion factor basically, and that is B moles of W divided by A moles of G. Now this should be multiplied by the given quantity, which is, if somebody asks you, if we have X moles, X is a number, X moles of G, how many moles of W we will produce as per this equation. So what you need to do, first of all, based on the question, the given quantity and the requested quantity, you get them into a mole ratio or a conversion factor. The conversion factor in this case, again, is B mole of W divided by A moles of G. And this is again derived from the equation, not, it's not something that I created. It is coming from or derived from the chemical equation in front of you, which is A moles of G to produce B moles of W. So the given quantity multiplied by the conversion factor will give you XB over A. Now, XB over A, these are all numbers, which is X is the moles that is given to you. B over A is the ratio between the coefficients of W and G, and that will equal to the moles of W. Let's take an example, real example. Forget about G and W for now, which is how many, let me just move this thing a little bit here, which is how many moles of ammonia are produced when 0.6 moles of nitrogen reacts with hydrogen. See here, he did not specify. Let me just put you on hold for 1 second. Okay, so the question is, again, how many moles of ammonia are produced when 0.6 moles of nitrogen reacts with hydrogen? So we're talking about the same equation of hydrogen and nitrogen to produce ammonia. All right, so anybody can tell me what is the given amount in this case? What is X? If you refer back to this equation, okay, the question is, okay, what is X moles of G in this case? Mole of nitrogen. Yes, and that is 0.6. Very good, yeah, Faisal Hussein. So 0.6 moles of nitrogen is the given quantity. And based on the chemical reaction, which you still remember, I assume, that is N2 plus 3H2 to produce 2 moles of ammonia. This is the chemical reaction. So what is the mole ratio between ammonia and nitrogen in this case? What is the mole ratio between ammonia and nitrogen? It is 1 to 2. Okay. Is there anybody other than Faisal who knows? Come on, guys. 1 to 3. لو ظل فيصل أحسن. Where's the threes coming from, ya Ghaida? We're talking about nitrogen and ammonia. So it is 1 to 2. We have 1 mole of nitrogen produces 2 moles of ammonia. So it is 1 to 2. But how can we write it? We write it as, now, are we going to write it as 2 moles of NH3 divided by 1 mole of nitrogen? Or shall we write it as 1 mole of nitrogen divided by 2 moles of NH3? Because we have the choice to use it this way or that way. The first one, which is this one. Why we use this one other than Faisal? I need somebody else other than Faisal. Why we going to use this mole ratio but not this one? Yalla, guys. Come on, I need the others to participate because we need it for nitrogen.
لأن النيتروجين حيروح مع النيتروجين.
Okay, yeah, that is true. So because we need to make sure, as I said last time, that the given quantity units should be in the denominator of the conversion factor. So the nitrogen should be in the denominator so we can cancel out with each other. That is true. So here what we need to do, first of all, as usual, we need to analyze. Okay, this is the chemical equation for you here. Let me just move this. Okay, so this is the chemical equation that we're talking about. The conversion is moles of nitrogen into okay, so the conversion is moles of nitrogen into moles of ammonia. And 1 moles of, in this case, we have 1 mole of nitrogen with 3 of hydrogen produces 2 moles of that. That's just analyzing the question. What are the known quantities? This is the 0.6 moles of nitrogen. What is needed to be known? The unknown is the moles of ammonia. Okay, so on that basis, we move on. So this is the conversion factor that we will use. How we decide? Because the given quantity is given for nitrogen. So all what we need to do is to multiply the 0.6 moles of nitrogen that is provided times this conversion factor. Then the moles of nitrogen goes with that, and that will be 1.2 moles of ammonia. Of course, anybody can do that with their eyes. Since it is 1 to 2, if it is 0.6, then it will go to 1.2. But I warned you last time that it is better, or it is strongly recommended that you use conversion factor, because that is what we call dimensional analysis. Because dimensional analysis is the one which will avoid any kind of mistake. So this is the way we multiply the given quantity by the conversion factor. The moles goes with the moles, and the answer will be in that case 0.6. The ratio of 1.2 moles of ammonia to 0.6 is making sense. So that is in evaluating your answer. Now, before we move on to the mass to mass calculation, let me just make sure that every one of you understand how to do what we call mole to mole calculations, right? Is there anybody who did not understand this? So interpreting an equation using the mole, which is reading it with the coefficient, is the right way to do it with the mole to mole conversion. If we want to do, anybody who have a question or something? Well, if it is clear for everyone, then I assume that we'll see how it goes now. طيب. Mass to mass calculation. What is the difference now when we say mass to mass calculation? We're going to start with the grams of the reactants, and we need to find the grams of the product instead of moles. But as you know, the way to go from any mass to any mass, it should go through the moles. If you remember that shape, I have to remind you with that again, which is, if you remember, we have the mole over here, and we have something like this. Here we have the volume, and here we have the mass, and here we have the particles. Going back and forth between mass and moles, it goes through the molar mass. Remember that. Forget about the volume and the particles for now, but conversion between mass and moles goes through the what? Go through the molar mass. So if we have the mass of 1 mole of any material, which is the molar mass, we can use that as a conversion factor to go from the mass of a material into the moles of material. Once we have the mass of the moles of the material, then we go back to the previous calculations, okay? So here's the steps that is we need to follow, which is again for an example of, G. This is the equation, which is A moles of G goes to B moles of W. If we provide you with the mass of G, which is grams, mass of G, and we ask you how many grams of W will be produced. So in that case, the first step will be to convert or to change the mass of G into moles of G. And how we do that? Using the molar mass conversion factor, which is 1 mole of G divided by the molar mass of G. That is a conversion factor. We multiply it by the given mass, and then the mass goes with the mass, and we end up with moles of G. Once we have the moles of G, which is here, then moles of G is multiplied by the conversion factor, which is, in that case, B moles of W divided by A moles of G. So the G goes with the G, then we end up with moles of W, right? So the second step will be changing the moles of G into moles of W, and that is by using this conversion factor, and that is coming from where? From the chemical equation. So again, mass to mass calculation. If we have the mass of one of the reactants and we want to find out how many grams of the product are produced, the first thing we need to do is to change the mass of the reactant into moles, and that is using the molar mass conversion factor, and that is this one. Once we get the moles of the reactant, then we convert it into moles of the product using the conversion factor from the chemical equation. Number 3 here will be to take back the moles of W back into mass of W and using the molar mass of the W. That's what we need to do. And that is step number 3, which is taking the answer here, which is the moles of W. We can multiply it by the molar mass of W by 1 mole, and that will get you into here. So we started up with mass of G, and we end up with mass of W. That's why we call that mass to mass calculations. Okay? So if you were given, again, the mass of one of the reactants, and you were asked to find the mass of the product, then in that case, they are made from 3 steps. The first step, of course, you're not going to memorize these steps. You need to understand them. But I'm just, we're making it in 1, 2, 3, so we'll make it easy for you to understand, not for you to memorize. Okay, so we have the mass or the grams of the reactant is converted into moles of reactant by molar mass conversion factor, then taking the moles of the reactant into the moles of the product using the conversion factor from the equation, and then taking the mass, the moles of the product back into the mass using the molar mass of the product. Here's another way of representing this, which is this is the chemical equation, as I said. This is the given quantity, and that is the wanted quantity. So in that case, we start up with the mass of G, which is given, multiply by the molar mass. That will get you into the moles of G. Then using the conversion factor from the equation, we can take you to the moles of W. Then using the molar mass of W will take you to the mass of that. So we were going from this side to that side through these 3 steps again. Okay, the question is if for mole mass problems. It's not always that the question will always ask you for mass to mass. It could be moles to mass. So if it is moles to mass problem, then the first step high, it would not needed. Then we started with from here. If, in another word, the mass mole problem is required, then this last step is not needed. And then we will start with the mass and end up with the moles. So this is mass moles. And the previous one over here is moles into mass. Okay? Is that clear? So it's not necessarily that always has to be mass to mass. Right. Let's see if that is true. Then you guys can do this example, right? All right, calculate the number of grams of ammonia produced by the reaction of 5.4 grams hydrogen with an excess of nitrogen. Why we say excess of nitrogen? Because the nitrogen is not in the calculation. That's the meaning of being excess. طبعا, when we take section 3, you will understand this better because there is something called the limiting reagent, and this means that the nitrogen is the one to be used in calculation. Anyways, don't worry about that for now. What is provided is 5.4 grams of nitrogen, and what is needed is to know the grams of ammonia. So this is basically a mass to mass calculation. So anybody can tell me how to do that? You know, what are the steps that we need to do? Just tell me grams to moles and stuff like that. So it will be, the first step will be, what is the first step? We need to convert the grams to moles. Which grams, ya Mazen? Grams of nitrogen into moles of nitrogen. That's what you mean. No, 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 not of hydrogen. ايش دخل الهيدروجين في الموضوع? Oh, yeah, I'm sorry. You're right, Faisal. We're talking about nitrogen is the one in excess. That's right, yes. So grams of hydrogen, wait a minute. That is actually should not be here. This should be here. Okay, so we have 5.4 grams of hydrogen, right? So we need to convert that into what? No, before that, yeah, Eileen, we have 5.4 grams of hydrogen. We need to convert it into moles of hydrogen. Okay, so بدينا نخربط، بلشتوا تغلطوا الطين في العجين. يلا, let's do it كمان مرة. Okay, so we have the equation here in front of you. Then what we have is the mass of hydrogen. We also know that 3 moles of hydrogen will produce 2 moles of ammonia. That is as per the balanced equation. 1 mole of hydrogen is 2 grams of hydrogen. You know, this is the molar mass. And also the molar mass of ammonia is 17. So how many the grams? What is the first step then will be? The first step, yeah, Eileen, is to convert the grams of hydrogen into, I mean, this is the whole plan, is to go from grams to grams. But the first step will be grams into moles of hydrogen, and then moles of hydrogen into moles of ammonia, and moles of ammonia back into grams of ammonia. And here we use which conversion factor in the first step? We use the molar mass of hydrogen. And going from the moles of hydrogen to the moles of ammonia, we use the conversion factor from the chemical equation, which is 2 to 3. And in going back from the moles of ammonia into grams of ammonia, we use the molar mass of ammonia. All right, so this is the first step, which is the given quantity is multiplied by the molar mass conversion factor of hydrogen, which is 1 mole of hydrogen divided by 2 grams of hydrogen. Then this should be multiplied by the second step, which is 2 moles of ammonia divided by 3 moles of hydrogen, where that is the mole ratio, which is derived from the chemical equation. Then after that, we multiply it by the molar mass of ammonia, which is 17 grams by 1 mole. So as you can see, this goes with that, this goes with that, this goes with that. What is left is the grams of ammonia, and that is 31. Okay, now evaluating such an answer using all these steps together will be difficult to evaluate your answer, but you can do that by understanding the following: is that here we have almost more than 5.4 grams is more than almost 3 moles of hydrogen, and this means that we're going to produce about 2 moles, little bit than 2 moles of ammonia. So that should be less than 34. That's the way you evaluate your answer. And 31 is an acceptable answer. Okay? So now we know how to do mole to mole. We know how to do mass to mass. We know how to do mole to mass or mass to moles. Okay? Let's take another example. Who wants to do this with me? You want me to pick names or you're going to volunteer? Faisal, no. غيرك. Anybody else? I need to see new names. وإلا, next time or now, I can open the list and pick on names and make it like a quiz. لأنه it's not acceptable that you'll be sitting there just, I don't know what you're doing. Okay? Anybody else? Other than I don't really get it, but I volunteer. Ya Dani Ibrahim, I ask if you get it or not. But anyways, that's a good strategy. Let's start with Dania and see which part you did not get it. And let's do it together, okay? Yalla ya Dania. Let's read the question first, which is, I'll read it with you. Phosphorus burns in air to produce a phosphorus oxide in the following reaction. The following reaction is in front of you, which is 4p solid plus 5 oxygen to produce P4O10. And that is, what kind of reaction is this, ya Dania? That is combustion, right? Because oxygen is one of the reactants. Right. Is the equation balanced? First of all, that is the first thing you need to check. It is balanced. So we can use the coefficient in there. All right. Now we're going to come to the question, which is what mass of phosphorus? Here, this is what is needed to be known. How many grams of phosphorus will be needed to produce 3 moles of this one? So if I were to produce 3.25 moles of phosphorus oxide, then how many grams of phosphorus I need? Yeah, Dania. So the plan will be, you need to tell me what is the plan now. We need to go backward, first of all. We need to transfer moles into grams. Which moles? The moles of phosphorus oxide. We need to change it into grams of phosphorus oxide. And once we, nah, is this right? Tanya, we need to transfer moles to grams of P. Do we have the grams of P? ما هو بسألك عن the grams of P. How would you do that? كمان مرة يا دانيا, you need to, first of all, need to know what you have and what you need to get. What we have is the moles of the product. And what I need to know is the mass of the reactant. So this is basically a mole to mass calculation. So first thing I need to do, ya Dania, is to go from the moles of the product into the moles of the reactant. So I don't use molar mass in this case. I use the ratio. 3.2 moles of this times 1 mole of phosphorus. Not like that, not quite like that. You multiply 3.2 moles of this. Yeah, that is times 1 mole of, or 4 moles of phosphorus divided by that. Let me show you that يا دانيا. بعدك بتلخبط الامور ببعض. you have 3.25 moles of P4O10. You need to convert this into moles of phosphorus. So my question to you, Yadania, don't do multiplication. Just show me or write the conversion factor that you will be using. ايش هو الconversion factor that you will be using? طبعا whatever applies to Dania is applies to most of you. I know that 90% of you don't know how to do it. 4 to 1. طيب بدل ما نقول 4 to 1 يا دانيا, let's write it. I want to write it in along with the units. So that will be, let me help you with that. The conversion factor we need is 4 moles of phosphorus divided by 1 mole of P4O10. This is your conversion factor. Okay, then you multiply this by the 3.25 moles of P2O5. عشان هيك ال P4O10 will cancel with that and it will be 3.2 times 4. Okay, let me show you exactly what will happen. This is the step that we're talking about here, Dania. This is the conversion factor which is derived from the chemical equation. This is the given quantity. So the answer to this, without these, the answer to this will equal to the what? To the moles of phosphorus. Then you use the molar mass of phosphorus in order to change it into grams of phosphorus by multiplying by 31 phosphorus by 1 gram, 1 mole of phosphorus, and that will give you 403 grams of phosphorus. Is that clear? Yeah, Dania first. Let's start with Dania. So you get it now? Anyways, it needs more practice, and not only for you, but also for the others. All right? So this type of calculation is basically called moles into mass, because we started with moles. And as you can see also from this example, that it is not necessarily that we always start from the reactants. We sometimes start from the product side. We start with the given quantity, regardless what kind of given quantity we have. Is it a reactant or a product? It doesn't matter. Okay. طيب, other stoichiometric calculations, which means that we did moles to moles, we did mass to mass. What is left? If you remember that any measurements of anything is basically count, volume, and mass. So we're going to use now the counts and the others in order to just hold on 1 second, okay? All right, so what other stoichiometric calculations we can do based on that? That will be the volume to volume or particles to particles. We can do that too. The typical stoichiometric calculation starts with the following. Any calculation, regardless of what given quantity you have, the given quantity is first converted into moles. So whatever quantity is given, reactants, products, given in grams, given in volume, given in particles, whatever it is, you have to convert it into moles. How you do that? Using one of the conversion factors that we used before, which is either the molar mass if we have a mass, or the molar volume if we have a gas under STP, or Avogadro's number if we have the number of particles. Okay, so this is the first step. All right. I want to make sure that everybody understands this before we move on to the second step. That the given quantity, regardless of the question, in any question, you will have a chemical reaction. Okay. That chemical reaction has to be balanced. If a given quantity of a reactants or a product is given to you, and that is either as a mass or as a particles or as a volume, then you can convert that into moles of that material. The second thing will be to use the mole ratio from the balanced chemical equation in order to calculate the wanted substance, how many moles of the wanted substance you have, or you need to do. And then the third step will be to take the moles that you get and convert that into the desired unit as per the question is asking you. خلينا ناخذ example and that will make it even better. Okay, so these are the kind of conversion factor that you need to remember, which is mole to mass ratio is using molar mass. طبعا either use this one or this one. You can use this one or this one. How you decide which one to use? Depending on the given quantity. If the given quantity is grams, then you have to use this one. If the given quantity is moles, you have to use this one. All right, so it depends on the quantity that you have. And the second conversion factor is the one that you remember, which is the for Avogadro's number uh, per 1 mole. And under STP for gases, we have 22.4 liters per mole, or 1 mole over 22.4 liters. All right, so these are the three types of conversion factor that we will use for the first step and the last step, which is to convert your given quantity into moles. طبعا ممكن تكون quantity already given to you in moles, so that step will be not needed in that case, right? So if you take a look at this map is like the previous one, and you have to remember this as much as you can. If you have a chemical reaction like this, which is A moles of G producing B moles of W. Again, G is any material or substance, W is another product, and A and B are the numbers. These are the coefficients. Okay, so if we provide you with the representative particles of G, somebody says, how many grams of W is produced from 10 molecules of G? ساعتها you have molecules, then you have to use Avogadro's number to convert that into moles. And then from the ratio going moles to moles, you have to use this one. You end up with the moles of W. Then the question was, how many grams? So I need to go from the moles into grams and get that. So that kind of calculation this way is particles into mass. It is possible to be mass to mass. It is possible to be volume into mass. It is possible to be particles into volume, or particles into particles. Regardless, using this map in front of you, you can do any conversion that you want. Either particles to particles, mass to mass, volume to volume, or you can have a mixed request, which is to go from any given quantity. بغض النظر, is it a volume, or is it a number of particles, or is it a mass, you still can convert that into moles. And once you get it into moles of G, then you have to go to the other side, which is the moles of W, using the conversion factor from the equation. Once you are here, then you can take it back into whatever the question is asking you. Is it asking you for particles? How many molecules? Is it asking you how many atoms? Is it asking you how many grams? Is it asking you how many liters? It depends on the question that you've been asked. Okay, so everybody needs to understand this shape in front of you so you can do any kind of calculation that you are requested to do. All right, is that clear for everyone? Hopefully. طيب. Now we're going to go back to the question that we had before, which is, how do you think an airbag manufacturers know how much to get or how to get the right amount of air in an inflated bag? Number is used only when the number of molecules are given, right? Not only the number of molecules, yeah, you're right, Iban. whenever number of molecules, but if it is possible to be a number of formula units. It could be number of atoms. It depends. Then Avogadro's number can be used for any representative particle. It could be molecules, could be atoms, could be formula, but you're right. Okay, let's deal with this question now. How do you think airbag manufacturers know how to get the right amount of air in an inflated airbag? Remember هذا السؤال تبع الairbag. We have sodium azide that is dissociated, or yeah, it will be separated into nitrogen gas and sodium. So how do you think they should know how much air they need to produce? Okay, so they need to know how many liters need to be produced, taking that liters of nitrogen into moles of nitrogen, and then take it back into well, under STP, that is right, بس مش STP with a small letter, لأن هاي ال STP that you written is not the one that we refer to. But anyways, yes, that should be under STP, of course. طيب. That's not the answer, Eileen. That's not under STP. That's, thank you very much for mentioning that, but that's not what we're looking for. What we're looking for is the following answer, which is they take the volume of nitrogen in the bag and convert it into moles. That is number one. And assuming STP. Then they use the moles ratio from the equation to convert it to the moles of the reactant. Then that could be converted to any other measurement related to the mole. Could be grams, could be particles, could be whatever. Even if it is a gas, then you can convert it into a gas. طيب. Let's see, we still have time. Yeah, we still have 5 minutes. All right, calculating the number of molecules. هذا السؤال بان, since she asked about Avogadro's number. شو رأيك بان to work with me on this one? Is that fine? No, you will do it, inshallah. How many molecules of oxygen produced when 29.2 grams of water decomposed by electrolysis according to the balanced equation? يعني, the question, Yaban, is how many molecules is needed if we give you 29.2 grams of water. First of all, I want you to tell me just the math, what we need to do, or what kind of stoichiometric calculation is this? We're starting with a mass. So what is we need to take that mass of water, convert it into what, Yaban? The 29.2 grams of water need to be to be converted into moles of water. That is very good. طيب, once we get the moles of water, then we need to convert it to see how many moles of oxygen. يعني مش O هيك, it's O2, بس ماشي الحال. طيب. All right, once we get the moles of oxygen, then we need to convert it into يلا يا بان كملي معروفك. احنا وصلنا that we have moles of oxygen into molecules بدون question mark, molecules of oxygen. How we do that, Iban? Going from the moles of oxygen into molecules of oxygen using which conversion factor? The Avogadro's number. That's what we ask about, you ask about. Then, first of all, we convert the 29.2 grams of water into moles using the molar mass of water. Okay, that will be your first step, which is, here's the plan. What you answer is basically is here, Yaban. We have grams of water, we take it to the moles. How we do that? Using this conversion factor. We take the moles of water into moles of oxygen using the mole ratio from the chemical equation. Then we take the moles of oxygen into molecules of oxygen using Avogadro's number, or 1 mole over Avogadro's number of molecules divided by moles of oxygen. All right. So in that case, then this is the information that is known for you, which is, first of all, you know that we have 29.2 grams of water. You know that 2 moles of water produces 1 mole of oxygen, and that is as per the balanced equation. You know that the molar mass of 1 mole of water is 18 grams, and you know that 1 mole of oxygen contains Avogadro's number of molecules. So basically, this is the first step, Yaban, to convert the grams into moles. And then this is to take the moles to moles from the water side to the oxygen side. And that then after that, we multiply it by Avogadro's number, and that will give you the number of molecules of O2 that is can be produced. Okay. I think we should stop right here because it is the time. But next time, inshallah, we will do uh, uh, this example, which is slide 45, and that is on volume. This way we got to review what we have done, but I strongly recommend the following for you guys. If you really need to understand this, by the time we come back on Tuesday and take the second lecture, you should review all what we have done so far. If you do that, then when you come, you will fill the gaps of the things that you don't understand. But if you leave it as usual, خليها بعدين لوقت الامتحان, then المرة الجاية بتكون قاعد زي ما انت قاعد اليوم. بس يعني مجرد مستمع، لا انت فاهم ولا انت عارف شو مسوي. Okay? والنتيجة معروفة in the exam. ف really this is again and again an answer to anybody who asks why I'm not doing well in the exams. This is the reason. You need to prepare the lecture, pay attention, review it when you go home. When we come back the next time and we talk about it, you know what we're doing. And that's it. Practice the homework, then you will be fine. I can guarantee you that you will answer all the questions in the exam. But if you don't follow this procedure, indeed you will not. Okay? Anything, any question, any? All right. So we'll speak to you either like this online on Tuesday, or I will come to the class. It depends. I will keep you posted.